Good morning. So today we're gonna do just some review. We're gonna look at scientific notation, and we're going to do a little bit about linears and just some numbers. So I'm gonna throw this in there throughout the rest of the semester for y'all. So in this question, it's kind of pertaining to what we've been going through, scientific notation. So it says, how many times larger is 8 times 10 to the ninth than 2 times 10 to the 7th? So how many times larger is 8 times 10 to the ninth than 2 times 10 to the 7th? So these are our scientific notation. So I want to see how big this 8 is compared to this 10. Okay, so how many times, so what I'm looking for, let's think about this. So if I have a something that's 10, and I want to find how many times larger it is, and I know that it's going to be, my big number is going to be 50. Okay, so here what I would do is I would divide both sides by 10. So anytime you want to figure out how big something is compared to another number, then all we're going to do really here basically is divide. Okay, so all we're going to do is to divide here. So we're going to take 8 times 10 to the ninth and divide it by 2 times 10 to the 7th. Okay, so let's think about this when we divide. Remember, when we divide, just imagine we don't have our calculator. So 8 divided by 2, so that is a 4, times 10 to the 9 minus 7, which is a 2. So 4 times 10 to the second, so that would be, remember, it's a positive exponent there, so you move your decimal 2 places. So how many times larger is 8 times 10 to the ninth than 2? It would be 400. Okay? Alright, look here. So, this one says, what is 2.5% of 8 times 10 to the 11th? Okay, so what is 2.5% of? So what does that mean I'm going to do? What does that of right there mean I'm going to do? Think about that for a second. Of means I'm going to multiply. So what I want to do is I want to multiply 2.5% times 8 times 10 to the 11th power. Alright, but remember, you can't just multiply your percent. So you have to change your percent to a what? Decimal before you can actually do the math. Okay, so a decimal, change it 2 places like this. So this is going to be 0.025 times 8 times 10 to the 11th. So I'm not sure if y'all are able to use a calculator on all these standardized tests that you do. So let's do this. So remember, it's going to be, we're multiply the number. So 8 times 0.0, well, let's do this. So we're not doing it so many times. So 0.025 times an 8. So that's 8 times 5, which is a 4. 40, what am I doing? I can't even do it. So 40. 8 times 2, which is a 16, plus 4, which is a then 20. 8 times 0 is 0. So this is going to be a 0.2 times 10 to the 11th. Because remember, when you multiply your scientific notation, you just multiply the numbers and then you add your exponents, but that one doesn't have 0.025. It's not in an exponential scientific notation form. So remember, then you go back to scientific notation. So, okay, I know you've probably struggled with this a little bit, but now I'm going to move it to the right here. So I'm going to subtract. So it's going to be 2 times 10 to the not 11th anymore, but to the 10th power. Okay. All right, so y'all look at this one and see if y'all can put these numbers in the correct equivalency. Okay, so these are all multiplications. So the 0.014 times 1.4. So let's do the math there. Okay, so 4 times 4 is a 16. 4 times 1 is 4, plus 1 is a 5. 4 times 0 is 0. So we won't worry about that. I need a little bit more room to do this. Okay, so 4 times 4 is a 16. 5, 0. 1 times 4 is a 4. 1 times 1 is a 1. 1 times 0 is a 0. So we'll add 6, 9, 1, 0. I have 1, 2, 3, 4. So I'm going to move my decimal place 1, 2, 3, 4. Okay. So those two numbers multiplied together are 0.0196. Okay. So for this first one right here, this one is going to be 0.0196, okay, times 10 to the 8th power. But remember, we'll put it in scientific notation. Okay, so we're going to move it to 1, 2 places. So it'll be 1.96, and we're going to subtract the exponent. So 8 minus 2, I moved it 2 places. So it's going to be 10 to the 6th power. So that would be our answer for that one. Okay. All right. So let's look at the second one here. So the multiplication of the numbers are still going to be the same, right? But the exponents is going to be 0.0196 times 10 to the negative first power there, negative first. Okay, so I'm still going to move it 1, 2, so it's going to be 1.96. I'm going to subtract my exponents. So it's going to be 10 to the negative 1 minus, I just moved it 2 places, to the negative 2. So negative 1 minus a 2 will give me a negative 3. Okay. All right, so let's look at that third one. The math of the numbers is still the same, right? So we're going to look at this one here, the third one. So it's going to be 0.0196 times 10 to the negative 3. Okay, so I'm going to move it 1, 2, so I'm going to subtract. So it's going to be 1.96 times 10 to the negative 3 minus a 2, which is a negative 5. Okay. All right. So now the math down here is a little bit different, even though it's the same number, just the decimals moved. So, but let's just go quickly and do 1.4 times 1.4 over here. So 4 times 4 is a 16. 5, 4, 1. So it's only 2 decimals, so 1, 2. So it's a 0.1 or 1.96. Okay, so when I multiply this one, it's going to be a 1.96 times 10 to the 1, 2, 3. So we add our exponents, right? So 2 plus 3, which gives us a 5. So then we know that the last one is going to be this one, but let's just do it as well. So what do we do? Here, so it's going to be 1.96 times 10 to the negative 2 power times 10 to the 4th power. So negative 2 plus 4 gives you a 2. Okay? All right. All right, so you'll try to do this one for me. So match each value with an equivalent numerical expression. Okay, so let's look here. So this one, I'm going to start with this one right here. So 2 to the negative 2nd power times 2 to the negative 2nd power. So, remember we talked about exponents. So if I was to multiply these two numbers together, this would be 2 to the negative 4th power. Okay? So 2 to the negative 4th power is going to be 1 over 2 to the 4th power. So 2 to the 4th power is 2 times 2 times 2 times 2, right? So that's 4 times 4, which is a 16. So this is going to be 1 over 16. So remember our rules of exponents. We've gone through those. There's reasons why we go through our rules of exponents. All right, here 2 to the 5th times 2 to the negative 2nd. I'm going to add those together. But technically it'll be subtracting, right? So when I do that, it'll be 5 plus a negative 2. So 5 plus a negative 2 is going to be 2 to the 3rd power. So 2 to the 3rd power is going to be an 8. Right, 2 times 2 times 2, which is 8. Alright, right here for this one, so we have 2 to the negative 2nd power over 2 cubed. So what do we do with those exponents? We subtract those. So 2 to the negative 2nd minus a 3 is going to be 2 to the negative 5th. Right? So 2 to the negative 5th is 1 over 2 to the 5th power, which is 1 over 32nd. Good? Alright, let's look at this one. So read through this one for me. Okay, so a nanometer can be expressed as 1 times 10 to the negative 9th meters. And a millimeter can be expressed as 1 times 10 to the negative 3rd meters. Alright, so out of these two numbers right here, which one is the bigger number? Okay, remember negative exponents mean the smaller of the negative exponents is going to be the bigger number. So 1 times 10 to the negative 3rd meters is bigger than 1 times 10 to the negative 3rd, or negative 9th meters, I'm sorry. So then let's read these options down here. So when you're taking tests, you might want to go and read through some of your questions. So here's my answers here. So it says a millimeter or a nanometer is something times larger than a millimeter nanometer. Okay, so there's my choices here. So it's looking for something is larger than the other one. So what we're going to do here is we're going to take the larger number just like we did on that other example. Where was it? Right here, the first one that we did. So how many times larger? So we're going to take the larger number, divide it by the smaller number. So which one of these is my larger number? That 1 times 10 to the negative 3. So 1 times 10 to the negative 3 divided by 1 times 10 to the negative 9th. So we divide, so it's 1. We subtract our exponent, so 10. Negative 3 minus a negative 9 is going to be a positive 6. So this is going to be, remember, 1 times 10 to the 6. We move it 6 places. So 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, pretty much, right? Okay, so what's happening here? So which one would go, which one is my bigger one? Put a box around it, but let's go look at the words. So a millimeter, right, is larger, so it's going to be 1 million times larger than a nanometer. Okay. We haven't done anything like this yet. We're going to do that later, but I think that you can think through this one logically, so just take a minute, read through it, and see what you get. Okay, so some number has to be raised to the third power, and it's going to be giving you a 64. So some number cubed is going to give you 64. So just think about that. Could I put 21 right there? That's 21 times 21 times 21. Just mathematically, that would be a lot bigger than 64, right? So we can definitely throw that answer out. 16 won't be in there because 16 is definitely, just think about that. 16 times 16 times 16, it's just never going to give you anything close to that. 8 times 8 times 8. So 8 times 8 is already 64, right? So if you multiply another 8, then that would be nowhere close. So your only option really is going to be 4. So what that means is that what technically you would be doing, 4 cubed, does it give you 64? And 4 times 4 is 16. And then 16 times 4 is 4 plus 2, which is that 64. Okay? All right, y'all look at this one. This is function notation, so think back about our functions and what we've talked about. We've talked about all of this. Okay, so which order pair should be removed to make the graph a function? Okay, so remember, to be a function, there can only be one x value mapped to a y value. Okay, so right here I see that I have multiple x values mapped to different y values here. Okay, so that does not make this a function. Okay, so since this isn't a function, one of these ordered pairs needs to be removed. So 6, 5 would need to be removed, and 6, 7 would need to be removed, or that 6, 3. Okay? All right, look at this one. Which functions are non-linear functions? So remember, a linear function is y equals that mx plus b, or where your exponents are both a 1. This is linear, right? So which ones of these are a non-linear? Okay, so a is definitely a linear function, but I'm looking for non-linear. So what happens right here? I've got a x squared, so that would not be linear. C is a form of a linear equation, but what about this one? This is not linear because that x down there in the denominator, when it's linear, it has to be 1 to 1. Okay? To be linear, it has to be 1 to 1. Where the x's and the y's are on the same equivalency there. This is in the denominator, so those are not linear. So both B and D here would not be linear. Okay? Y'all do this one for me. Okay, basically telling you, are these true statements here? Are these true or false? So take a minute and... Okay? Before I even go through anything, this one is multiplied by 0. Okay? So it says it's going to be multiplied by 0. Is that true? Because remember, 2 to the 0 power, 2 to the 0, anything to the 0 power is going to give you a 1. So this one can go ahead. We don't have to worry about that one at all. That one is going to be definitely false. Okay? All right, let's look here. So 2 raised to the 2 raised to the third power. So that, what does that mean? 2 to the 2 raised to the third power. If I wanted to simplify, what do I do to those exponents right there? I'm going to multiply, so 2 times 3, which gives you a 6. Okay, so 2 to the 6th times 2 to the negative first power is 1 over 2. So this one would be a true statement. Okay. Okay, let's look at the second one here. So, if I were to multiply, hold on, I think that wasn't multiply 2. Okay, so I want to multiply all these together. So 2 to the negative 9th times 2 to the 3rd times 2, we could call that 2 to the negative 4th power. So we're going to say 2 to the negative 9 plus 3 plus a negative 4 power. So negative 9 plus a 3 is a negative 6. Negative 6 plus a negative 4 is a negative 10. So this is going to be 1 over 2 to the 10th power. So this one is going to be a true statement. Okay. All right, what about that fourth one right there? So, if I were to change those, so this would be 2 times 2 to the negative 9th power times 2 squared here. So this would be 2 to the 1st plus a negative 9 plus a 2. So that right there says a positive 9. So this one is going to be a false statement. Okay. And then your last one, let's look at your last one here. So the last one is 2 to the 3rd raised to the 4th. And what do we do to those exponents? We multiply those. So 3 times 4, which gives you a 12. So that's also going to be a false statement. Okay? All right, let's look at this one here. So y'all determine, is the solution less than 5, equal to 5, or greater than 5? So, let's think back a little bit. So 5 squared is 5 times 5, right? Which is a 25. 5 cubed is going to be 25 times 5, which is a 125. Okay? So, 5 squared equals a 25. Alright, so 5 squared, do I see that anywhere? So the squared is going to be equal to 25. So that is going to be equal, the answer to this will be equal to 5. The x cubed down here is 125, and that one is going to be equal to a 5. Okay, look at this one. The x squared is equal to 50. So I know that my 5 squared is 25, so the x to this one is going to be greater than a 5. X cubed here is a 49, so x cubed is equal to 49. So that means something cubed has to give me a 49. Well, I know x5 cubed is 125, so I know that that's got to be less than a 5. Same thing with this x cubed is equal to a 36. It's going to have to be less than 5 to be able to make sense in this equation here. And then x cubed is equal to 15, also is going to be less than 5. Okay, so hopefully that'll help just kind of get you back in the swing of remembering things and not use it and lose it. So if y'all have any questions about anything, let me know. Y'all have a great day.